Okay, so today we're going to start section 4 from chapter 1, and it'll be day 1, so it'll be 1.4a. And the first thing that we're going to cover is to solve by factoring. So when we solve by factoring, we're going to get all the terms to one side, and we're going to be setting our equation equal to 0. After we have it set up like that, we're going to factor the equation. After we factor the equation, we're going to set each term or each parentheses equal to 0 and solve. Now, in the problems where we're just factoring out a GCF, that GCF will not be in parentheses. That GCF will still get set equal to 0 because it will become one of my solutions. So let's take a look at our first example. Now, I could also solve this by using the square root method, but right now all we're talking about is solving by factoring. So I'm going to go ahead and factor this. This happens to be the difference of two squares. So I'm going to factor it into two binomials, x plus 1, x minus 1, and it's still set equal to 0. Now my next step is to take each binomial or each factor, set them each equal to 0, and solve for x. Subtract 1, x equals negative 1, add 1 to this one, and x equals positive 1. So this has two solutions. It's x equals 1 and negative 1. You might also see the answer written as x equals plus minus 1. So it's just a little shorthand way of representing the solution. Now later on in this course, when we start talking about quadratic functions, we're going to be graphing these. And when we factor and solve, what we're essentially doing is finding where our graph touches the x-axis. So these are really our x-intercepts. But for now, all we're doing is classifying them, or the instructions will say to solve. My next equation is also already set equal to 0, so now I'm going to begin my factoring process. Again, I'm either looking to see, is it the difference of two squares? Is it a perfect square trinomial? Or is it just a regular trinomial that could be factored? In this particular case, it's neither of those special cases, so all I'm going to be able to do on this particular problem is factor out a greatest common factor. And my greatest common factor here is going to be x. So I'm going to divide each of my terms by x. And now my equation is factored. And again, I take each part, this term, and I'm going to set each one equal to 0. The first term, the x, is already solved. I don't need to do anything there. But the second one I do need to solve. So I'll subtract 1 and then divide by 3. So my second solution is x equals negative 1/3. So this has two solutions. My next equation is not in the correct form, so I do need to set it equal to 0 by subtracting x from both sides. X squared minus x equals 0. I need to look to see what type of equation I have. Is it a special case? No, it's not. So the only thing I'm going to do here is factor out a greatest common factor of x. I now will take each one of the terms, set them each equal to 0, and solve. Again, the first one, I don't need to do anything. The second one, I'm adding 1. So my two solutions are x equals 0 and x equals 1. My next example is a trinomial. I can factor this trinomial. What I need to do is find the factors of negative 8 that when I combine those factors will give me a positive 2. And those two factors, or multiples of negative 8, are going to be x plus 4 and x minus 2. Again, what you can do is do a quick FOIL. If it does not go back to the original, then maybe you've put the signs on the wrong numbers. Again, take each one of your factors, set it equal to 0, subtract 4, x equals negative 4, add 2, x equals 2. So it has two solutions, -4 and +2. Number 5, again, I need to get it in the correct form. So I need to go ahead and set it equal to 0, which it is. And now I can either factor this using guess and test, and it's pretty reasonable. There's only only one way to multiply to get a 2. It's 1 times 2. And then the factors of 15 are either going to be 1 and 15 or 3 and 5. So I could reasonably guess and test here, or I could also factor by grouping. I'm going to go ahead and guess and test. So here, my factor of 2x squared, I'm going to put here. So it's 2x times 1x. And then my factors of 15, I'm going to go ahead and try 3 and 5. I'll go ahead and put the +5 first, and then the -3. Again, do a quick FOIL, make sure it does go back. It does. So let me go ahead and solve now by setting each equal to 0. Subtract 5, 2x equals -5, divide by 2, and x equals -5/2. Add the 3, and x equals +3. Now, if we were graphing, I would probably make that improper fraction a decimal or a mixed number. I'm not graphing, so I'm just going to leave it improper. Now, for those of you who are not good at guessing and testing, I can also factor by grouping here. So let me rewrite my original equation. I'm going to keep that the same, keep the -15 the same. What I'm replacing is this middle term. Now remember, when you factor by grouping, you need to multiply the first term with the last term. So I'm looking for factors of -30x squared, two numbers that'll multiply to give me that, but who will also add to give me the -1x that's in the middle. So if I start listing my factors, it's 1 times -30, 2 times -15, 3 times -10, and 5 times -6. And the one that works is the 5 times -6. That's what I'm replacing the middle with. So I'm going to go ahead and put in the -6x first, and then the +5x. Again, it doesn't matter the order you put them in here. And then you would make your groups. GCF here of red is 2x. GCF of green is going to be +5. These two are the same, write it once, and then take the two GCFs that you just divided by. And then notice this answer that I just got is the same as when I guessed and tested. So again, I don't care which method you use for factoring, just use the method that's going to work best for you. Okay, next, I need to do number 6. Again, my first step is to make sure that it's set equal to 0. So I'm going to subtract the 3. So I'm going to first get it in the correct form. So I'm going to subtract 3 from both sides. And I get 2x squared plus 9x plus 4 equals 0. So now I need to try to factor this. I can either guess and test, or I can factor by grouping. For this, again, I'm just going to go ahead and guess and test, because there's only two factors, or one way to multiply to get a 2, 1 times 2. And for the 4, it's either 1 times 4 or 2 times 2. So let me go ahead and guess and test. So I'll put a 2x here and a 1x here. And then either I'm going to try the 1 and the 4, or the 2 and the 2. Let me try 1 and 4. Notice both signs are positive, so both signs of my binomials will be positive. And this is actually the one that works. Really, all you need to do is test the outer and the inner. Inside gives me 1x. Outside gives me 8x, and when I add them, I do get 9x. So this is the correct factors with the correct signs. So now let me go ahead now and set each of my factors equal to 0. So 2x plus 1 equals 0, and x plus 4 equals 0. Subtract 1. 2x equals negative 1, divide by 2, and x equals negative half. Same thing here, subtract 4, and then my solution here is x equals negative 4. So my two solutions are negative half and negative 4. Let's try number 7. Again, I need to set it equal to 0, so I need to subtract 3x. 6x squared minus 3x equals 0. Divide by the GCF. Set each of the factors equal to 0. Divide by 3, and x equals 0. Over here, add 1, divide by 2, and x equals 1/2. Okay, so for the next example, the same thing. I need to set it equal to 0. So I'm going to subtract 2x from both sides. And again, it's not a trinomial. It's not the difference of two squares. So again, I'm going to factor out a GCF. I'm going to set each factor equal to 0. 2x equals 0. 4x minus 1 equals 0. Divide by 2. And x equals 0, add 1, 4x equals 1, divide by 4, and x equals 1/4. Let's try another. So again, I need to set it equal to 0. So I'm going to add 6x to both sides. X squared plus 6x equals negative 9. Add the 9, x squared plus 6x plus 9 equals 0. And if you recognize this, this to me looks like it's a perfect square trinomial. We could double check it by square rooting the x, square rooting the 9, square root of x is x, of x squared is x, square root of 9 is 3. Double it, if it gives me the center or the middle number, then it is a perfect square trinomial. And remember, this result is always a binomial squared. So you can write it like this, or if you did not realize that, you would look for the factors of 9 that give you 6. Okay, and x plus 3 equals 0. This time when you go to solve, you don't need to do both, just do one, and x equals negative 3. So in this particular problem, there would only be one solution. If you were graphing this, it would only touch the x-axis one time. The next one, again, this is also a perfect square trinomial. Again, I could do the check. Square root the 4x squared, get 2x, square root the 9. And then if I multiply them and double it, it does give me 12x. So this result is a binomial squared. Or again, if you'd rather write it as 2x plus 3 and 2x plus 3. Again, you're only having to solve one of them for x because the solution is the same. Divide by 2, and the one solution is x equals negative 3/2. Number 11, this looks very similar to number 4 in the examples. The only difference is the sign in the center is now a negative instead of a positive. So my factors are the same. It's going to be the 2 and the 4, but this time the 2 is positive and the 4 is negative. X plus 2 equals 0, x minus 4 equals 0. Subtract the 2. Add the 4, and x equals negative 2 and positive 4. Two more examples of solving by factoring. So again, I need to set this equal to 0. I'm going to go ahead and add x squared. Actually, let me just show you this one. I'm going to move the 3 over, but then I'm going to divide everything by -1 or factor out a GCF of -1, just so that my x squared term is positive. So again, I would factor out a GCF of -1. And now what I need to do is factor the trinomial. Factors of +3 that give me -4 are going to be -1 and -3. Again, set each piece equal to 0. Notice when you do the GCF of -1, this doesn't make sense. There's no variable to solve for. So we really don't need to set that equal to 0 when it's a constant. Then I do need to do the other two binomials. Add 1, x equals 1. Add 3, x equals 3. So this has two solutions. It's 1 and 3. The last one has a fraction. I'm going to go ahead and multiply everything in my equation by the common denominator, which is 8. So I'm going to multiply my entire equation by 8, every piece. And this gives me x squared minus 8x minus 128 equals 0. I'm now looking for the factors of -128 that give me 8 when I add them. And this is going to be -16 and +8. I set each factor equal to 0. Add 16. X equals 16. Over here, subtract the 8. And x equals -8. So this is the end of the examples for the solve by factoring. Next, what we're going to do is solve by square root. So when we're solving equations by square rooting, we're going to get the squared term to one side, and then we're going to square root both sides by putting a plus-minus sign in front of the root. On any of the questions where that square root could be simplified, we will be leaving things in simplest radical form. Okay, so now we'll do some examples. Again, to solve equations by square rooting, you get the square term to one side, square root both sides, and you're going to put a plus-minus in front of the root. If the root could be broken down, you will leave it in simplest radical form. When you do the homework for the WebAssign, it's also going to ask you to give the decimal form. So you can go ahead and use your calculator for that part of the answer. So when you're breaking these down, if it's not a perfect square, you will leave it in simplest radical form as one of the answers, and then you'll also give the decimal. So it's going to ask for multiple different answers on some of the questions. So let's try some of these. So the first one is, and I'm just going to leave them in simplest radical form. So when you go ahead and you're working on this one, you are going to, it's already isolated, so I'm just going to square root both sides of my equation. When you square root the square, it cancels it, and now you're left with plus and minus the square root of 15. If the square root of 15 could be broken down, I would break it down, but it only factors into 3 times 5, so there aren't any pairs in there, so I leave it. For the next one, again, the square term is isolated, so again, I would square root both sides of my equation. I'm left with x is equal to plus and minus the square root of 48. Now, the square root of 48 can be simplified, so I'm going to break it down. I could go with 16 times 3. Now, at this point, if you realize 16 is a perfect square, and this would be your answer, plus or minus the square root of 4, or 4 square root 3. Now, if you didn't realize that, still at this step, you'd have to keep breaking down. And you can keep breaking until you have prime. and then go back and look for pairs. And these are all still under radicals. Once you make a pair of the radicals, then one of them comes out. So a 2 will come out here, a 2 will come out here, multiply them back, and you get 4 square root 3. So it's good if you can recognize the perfect squares, then you don't have to bring it all the way down to prime. Let's try number 16. Again, my square term has been isolated. It's all by itself on one side of the equation. I'm going to go ahead and square root both sides. And then the squaring and the square root will cancel each other out. I'm left with 4x plus 1 is equal to plus or minus the square root of 20. Again, I need to break down the 20. I could break it down to 4 times 5, which becomes 2 square root 5. So now I have 4x plus 1 is equal to plus or minus 2 square root 5. I'm trying to find the value of x, so I still need to work on getting x by itself. So I'm going to subtract 1. And then I'm left with 4x equals negative 1 plus or minus 2 square root 5. One more step, divide by 4, and x is equal to negative 1 plus or minus 2 square root 5 over 4. Now, don't be tempted to try to simplify the 2 and the 4. If you're going to reduce any of the fractions, you need to be able to reduce the 4 and just make sure you can simplify with both numbers that are outside of the radical. So because I can't simplify the 1/4, I'm going to leave the 2/4 alone. Let's try number 17. Again, your first step would be to isolate the squared term. So I'm going to add 43 to both sides. I get x squared is equal to 43. Now I'll square root both sides. And then I get x is equal to plus or minus the square root of 43. 43 can't be broken down, so I leave it alone. Let's try number 18. So again, your first step is to isolate the squared term. So I'm going to divide both sides by 9. X squared is equal to 36 divided by 9 is 4. And now I square root both sides, and x is equal to plus and minus 2. The next one, again, I would isolate the square term. X squared is equal to 37 over 25. And now I need to square root both sides. And now x is equal to plus and minus. I can square root these individually. So then I'm left with the square root of 37 over 5. Remember, if there was a radical left in the denominator, we would have to rationalize, but 25 was a perfect square, so it came out. Let's try number 20. Your squared term is already isolated, so I'm going to square root both sides. Square root this side, square root this side, and now I'm left with x minus 5 is equal to plus and minus 5. Now, when this ends up being a perfect square and it comes out of a radical, I'm going to actually do 2 problems here, but let me first move the 5 over. So now I have x equals 5 plus or minus 5, and I actually have to do the math here. So I actually have to do, when the radical disappears, write it out as first do x 5 plus 5, and then I'm going to do 5 minus 5. So this gives me x equals 10, and this gives me x equals 0. So you actually have to do the math when all the radicals cancel out. Let's try number 21. Again, I'm going to square root both sides. Let me go ahead and rewrite the problem. So I square root the left side and the right side. This gives me x plus 9 plus or minus the square root of 24. So I'm going to go ahead and I need to simplify the square root of 24. So I could do 4 times 6. 4 is perfect. 6 only becomes 2 times 3. No pairs in there, so I'm going to leave it to radical 6. So x plus 9 is equal to 2 plus the square root of 6, and then I need to move the 9. So x is equal to negative 9 plus or minus 2 square root of 6. Number 22. These will be the last two examples. So again, make sure your square term is isolated, which it is. So I'm going to square root the left side and the right side. Square rooting the square makes the 4x plus 7 come out of the radical. This becomes plus and minus the square root of 44. 44 I can break down into 4 times 11. So this becomes 2 square root of 11. So 4x plus 7 is equal to plus or minus 2 square root of 11. Move the 7. 4x equals negative 7 plus or minus 2 square root of 11. And now I need to divide by 4. So x is equal to negative 7 plus or minus 2 square root of 11 over 4. Again, nothing to simplify, so I leave it just like that. The next one has 2 radicals involved. So what I'm going to do here is I'm going to FOIL both sides. So here this would become x squared. So if you know the pattern, you square that, then the middle term is x times 5 times 2. So that becomes 10x plus 25, x squared plus 8x plus 16. So what I've done, if you're not sure on the pattern, write it 2 times and FOIL it. Same thing on the x plus 4. Now I'm going to try to group my like terms. Notice when I try to move the x squareds together, they cancel. So then now I'm left with 10x plus 25 equals 8x plus 16. Next, I'll try to move the 8x over. 2x plus 25 equals 16. Move the 25. 2x equals negative 9. Divide by 2. And x is equal to negative 9 halves. So that is it for the notes for section 1.4a. You do have a WebAssign assignment, so check for, log into WebAssign, look for the assignment. Remember, you need to show your work and then also screenshot your score, input the picture into your work, and then submit the work along with your score into Canvas. That's it.